All right, let's go ahead and take a look at example 3 here. It says at 4 degrees Celsius, 4 cubic feet of silver has the same mass as 42 cubic feet of water. At 4 degrees Celsius, would 210 cubic feet of water have the same mass as 20 cubic feet of silver? So there's some extraneous information here as far as the calculations we're going to do, and that's these 4-degree figures. All they're doing is they're pointing out that it's the same scenario, but it's not actually anything we're going to use in our calculations here. All right, what we're going to use is from the first line that it says 4 cubic feet of silver has the same mass as 42 cubic feet of water. So there's our first fraction, which is, you can see here on the left as it's written, 4 over 42. What do those two things represent? Well, the 4 is the cubic feet of silver, and the 42 is cubic feet of water. Now, from sentence 2, I'm going to be able to write a similar fraction that compares silver to water. What they're saying here is 210 cubic feet of water being equivalent to 20 cubic feet of silver. Now, what you have to be cautious about is we have to, when we're figuring out if these two things are the same, is we've got to set up our fractions the same way. Since I wrote silver over water on the left, I have to do the same thing on the right side there. So when I do that, that's why they're writing 20 over 210. Yes, I understand that 20 came last in the sentence, but 20 represents silver, and silver is on the top. And the 210 is for water, and that's on the bottom, so it's got to be written on the bottom. And what we have to figure out now is if those two guys represent the same thing. Now, there's a couple different ways to go about this, but as you can see, what they've done is they've reduced these fractions down and shown that they are the same, which is going to help us lead to the answer that is, yes, these two do have the same mass representation here. 4 over 42 can chop 2 out, which is the greatest common factor, and get 2 over 21. And again, when I'm saying I'm chopping 2 out, I'm doing the same to the numerator and the denominator. With 20 over 210, I'm taking 10 out, again, both to the numerator and denominator, and I get 2 over 21. Since those are both 2 over 21, that shows they are proportional, and the masses of silver and water then are in proportion. Again, we can do the cross multiplication like we talked about earlier. Another thing we can do is just look at the common multiplier here. To go from 4 to 20, you're multiplying by 5. So I'm going to do the exact same thing in the denominators there. And if that same multiplier works, times 5 to go from left to right, that would imply that they are in proportion. If it's something else, because it would be different numbers for the numerator and denominator, they would not be in proportion. But indeed, 42 times 5 is 210, which indicates that they are in proportion. All right, so let's go ahead and finish this up. Number 1, they're asking us to find two ratios that are equivalent to the given ratio. Again, it does not have to be something like simplest form where we're always making something smaller. You can make something bigger. So 8/16, as you can see, one of the things they wrote there is 2/4. Why? Well, that means they chopped 4 out of both the numerator and the denominator. Did they go to simplest terms? No, not necessarily, because we know that 2/4 would go down to a half, which really would be chopping 8 out of both the numerator and denominator. And that would be a perfectly acceptable answer as well. Notice their first answer comes from doubling both the numerator and the denominator, which is how they get away with writing 16 over 32. All right, number 2, 14/49 and 16/36. They're asking us to tell whether the ratios form a proportion. Now, looking at their answer, what that means they had to have done to check this is they would have had to have reduced the fractions. All right, well, let's reduce the fractions. This is not difficult. With 14 and 49, we can chop 7 out of 14 and 49. Why? Because that's the greatest common factor of 14 and 49. When we chop 7 out of each of those guys, that's where I get 2 7s from. With 16/36, the greatest common factor of 16 and 36 is 4. So I can chop 4 out of both of those guys, and that's how I get 4 9ths. And so the question is 2 7ths the same as 4 9ths? Well, no. 2 7ths is not the same as 4 9ths, which means the ratios are not in proportion. And remember, you've already seen a whole bunch of other ways that you can make that question work that might be easier for you. Whether that is multiplying the diagonals or changing these to decimals, whatever you have to do to check that out, you do. Doesn't matter which one, any one of them will give you a valid answer. Alright, let's look at the last one, number 3. For every $50 Janice earns, she gives $5 to charity. For every $20 Brenda earns, she gives $4 to charity. Do the girls give the same proportion of their earned money to charity? Alright, so it said for Janice, for every $50 she makes, or every $50 she earns, if you want to use their words, she gives $5 to charity. So notice the way I've written that fraction, it's earns over gives. So when I write this other fraction for poor Brenda, all right, I'm going to have to write this fraction the exact same way to check this out. It says when Brenda earns $20, earns number on the top, she gives $4 to charity. And they want to know if those two things represent the same thing. Well, again, you can use any of the techniques you want here to solve this. Most of you, what I'm guessing you're going to do, are going to divide both these out, reduce them, and see if they go to the same thing. Because 50 over 5, that's really easy. We're taking 5 out. That's 10 over 1. And when I do 20 over 4, well, I could take 4 out of both of those guys, and I end up with 5 over 1. Since those two fractions are not the same, that means no, they are not giving the same proportion of their earned money to charity.